In our previous video, we had learned about force, its type, and its property. Okay. In our this video, we are going to learn about the pressure, what it is, what are the impacts, and how it works. Okay. Let's start. What we understand by pressure. Pressure is a physical quantity which determines the impact of force applied on any object, right? Suppose I am having this surface. Now I am going to apply a certain force on this particular surface. Suppose I am having this particular pen and I am going to apply a force on this surface. So what will happen? The force applied on this surface or the area covered is known as pressure. Let's see mathematically. Suppose I am having a area. Okay, this is my area of a surface that I denoted by capital A. I am applying like this a force on this particular area, right? So my pressure is going to be P is equals to force upon area. Force per unit area is known as pressure. The unit, what is going to be unit of this particular pressure? Pascal. That is written as capital P and A, right? For remembering this formula can be broken into many forms, right? First form, what we have, P is equals to F by A. I can also write A is equals to F by P. And one more thing can be found, that is F equals to P by A, right? Now, we can remember these three formulas of pressure by this particular triangle, right? Suppose F is equals to the product of these two. P is equals to F by A is equals to F by P, right? Next, impact of force depend on the area, right? So suppose I am having some area A. If the area increases, what is going to happen? If the area increases, what will happen? If I am saying that my pressure is same, so my force will be proportional to area. If area increases, force will also increase. If area decreases, force will also decrease, right? Okay. Or in other words, we can say if my area increases, then my pressure is going to decrease. Or if my area decreases, then my pressure will be more, right? Due to this relation, we use this particular relation in many day-to-day life activities. For example, the straps of our bag, right? Here in picture you can clearly see that they make broad. Why? Because if the area is more, pressure is going to be less, right? Broader straps, lesser the pressure on our shoulders, right? If the straps are going to be thin, what will happen? The pressure will be more. That can hurt our shoulders, right? Another example is knife. Everyone had seen the knife. How it is having a sharp edge. With the help of that, we can cut fruits and vegetables, right? So here we are having a general ray diagram of knife. Okay, this is a sharp knife and this is a blunt knife. What will happen? What we can observe here? Here the area is less, but here the contact area is more. So obviously this type of knife will apply more pressure, whether this type of knife apply less pressure, right? So more pressure, so the vegetables will cut very well. Less pressure, the vegetables will not cut properly, right? This is the impact of pressure. Next type of pressure is atmospheric pressure. This pressure we had seen that in solid objects, right? Like solids, pressure is also there in gases and liquids. Okay, so gas and liquid also apply pressure, right? What is atmosphere? We all know that our earth is surrounded with plenty of air around us, which is known as atmosphere, and it is divided into different layers, right? Okay, so earth is in center and the envelope of air is there surrounding. Air made of gases. Gases also has some weight, right? So that weight of the air column on the surface of the earth apply a pressure. That pressure is known as atmospheric pressure, right? The unit of atmospheric pressure is bar. Let's have an example. Here I am having earth and I had considered a column of air. This is a column of air that I had considered on the earth, right? Let's take it, this column in this ray diagram. Okay, so this is my surface of earth. This is my column. This column is completely filled up with the air, and this air is going to apply pressure on this surface, and that is known as atmospheric pressure, right? It is written as PA, atmospheric pressure. Unit of atmospheric pressure, bar. Okay, as I said that liquid and gases both apply pressure. Okay, we had seen an example of atmospheric pressure, how the air applies the pressure on the surface of the earth. Now liquid, how liquid exert pressure, right? If I am going to fill the liquid in container, any container, right? Suppose I am having this container is completely filled with the liquid. It can be any type of liquid. Okay, so the molecules of the liquid are going to apply force on the wall of the container. Okay, again the force which is applied on the area inside the container. So this type of force per unit area is known as liquid pressure. Okay. Okay, so here I had taken a tank which is completely filled with the water. Okay, so on the top surface, this is my top surface of the liquid, right? On this, and this is in contact with air, so atmospheric pressure is going to act on this particular layer. So here what type of force is acting? Atmospheric pressure, force per unit area, force is due to air. So we had layered the liquid into different layers, 1, 2, 3, 4. Okay, now what we are going to do, we are going to make holes, right? So what will happen? If this hole is there, the water will fall down. What will happen? If we have this hole, the water from this particular hole is going to leak with certain angle. Now I am having this particular hole. What will happen? The water from this also come out with certain angle. With certain angle. And here also the water will come out with certain angle. What you people observed over here? What is the observation? Right? All the holes, from all the holes, the water is coming out with different angles. Why? What this is happening? Okay, here if we watch out in this particular container, what is happening? The pressure is acting towards the base also. The pressure is acting towards the walls of the containers also. Right? What happens over here? The pressure over here is more than the pressure over here. Right? As we go down inside the container, the value of pressure increases. Okay, this all the holes are having same area. So what will happen? We all know this formula. Area is constant. That means as the pressure is going to increase, your force is also going to increase, right? So here the pressure is increasing downward direction. The force applied on water also increase, due to which you can see that this is because of my fourth layer, this is because of the third layer, this is because of second layer, this is because of the first layer, right? So the distance or traveled by the water is getting increased. Okay, next two more activities we are having about pressure. If I am having a container and I am trying to immerse this particular ball inside the container. Okay, I am applying a force F downwards, right? What will happen over here? The ball will still down? No. Water also apply force on this particular, right? So this is the weight of your ball, but the water is also applying a force on this particular ball, so the ball will float. Okay. Okay. Next, if I am going to drink water with the help of straw, here I am having a red water. Okay. From here I am going to suck water inside. What are the values of pressure which are acting over here? On the top, I am having atmospheric pressure because it is open in the air, and some P value of pressure P I am applying from this particular. What will happen? If this atmospheric pressure is equals to this pressure, the liquid will not rise inside the tube or inside the straw. If my atmospheric pressure is less than this P, again there will be no rise. If my atmospheric pressure is more than applied pressure, what will happen? This pressure is going to be more. So this pressure will allow the liquid to rise inside the tube. As the liquid rise inside the tube, it will be there in our mouth. Okay, so this is the trick which is actually based on the atmospheric pressure, which help us to drink the juice from the straw. Okay, so this is all about the complete chapter. What we had learned over here, force is a physical quantity which is having magnitude as well as direction. Okay, force arises due to interaction of two objects. It can be contact or non-contact. Force per unit area is known as pressure. Okay, liquid and gases also exert pressure. They exert pressure on the walls of the container. Okay, so pressure exerted by the air column on the earth is known as atmospheric pressure. Okay, thank you everyone. Have a good day.